Section 3 in Unit 3 is titled Squares and Square Roots. Standard 7 NS2 is being able to understand the inverse relationship between squaring and square rooting a perfect square integer, and also that you can find the square roots of perfect square integers. So first, some vocabulary terms to write into your notes. Perfect square is a number that's the square of an integer. And the square root is one of two equal factors of a number. The radical sign is the box, or some students compare it to the division symbol, but it's kind of like a check mark over the perfect square. And the radicand is the value under the radical sign. So first I simply want you to find each square root. So you're looking for a number that when you multiply it times itself you get 9, so the square root of 9 would be equal to 3. Number 2, it's the square root of 64, but we want the negative square root of 64. So the number times itself that gives you 64 is 8. We want the negative of that, so we want negative 8. 3 is read plus or minus the square root of 7. Plus or minus the square root of 4. The plus or minus just means we want the positive and the negative root. So the square root of 4 is 2, so you write your answer as plus or minus 2. Three more examples of finding square roots. Number 4 is the square root of negative 81, and this is where you have to be careful. When you have this negative number inside the square root or under the square root, there actually isn't a number times itself that's negative 81. So some of you might think, well, 9 times 9, well, that's positive 81. And actually negative 9 times negative 9 is also still positive 81. And because the roots of square roots have to be the exact number times itself, here we're going to say no real solutions. And this is what you say when the negative is under the square root. Number 5, we have the negative square root of 49, so that's negative 7. In number 6, again, a plus or minus the square root of 16. So the square root of 16 is 4, so that would be plus or minus 4. Next, we want to estimate square roots. So when an integer is not a perfect square, you can still estimate it mentally by using perfect squares. So the example we're going to use here with this number line is going to be the square root of 33. I'm asking you to estimate the square root to the nearest integer. So you know that 33 is not a perfect square. What we need to do is figure out what perfect square is just below 33 and what perfect square is just above 33. So if you start thinking, I'll just start with 4. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So 25 and 36 are what the square root of 33 falls in between. The square root of 25 is 5. The square root of 36 is 6. And because 33 is closer to 36, then we would estimate the square root to be about 6. And this is like an equal sign that's squiggly marks. That means it's about equal to. So it's closer to 6 than it is to 5. And since it says to the nearest integer. So we want a whole number, we don't want any decimals or fractions yet. So starting with number 7, we're going to draw our number line. I want to be careful here because we're looking for negative roots. So one bigger than the negative square root of 129 would be the negative square root of 121. Whoops, that negative sign should be on the outside. So that would be negative 11. And on the other side, you have the negative square root of 144, or negative 12. So 129 is closer to 121. So we would say that the negative square root of 129 is about equal to negative 11. Number 8, we have the square root of 60. So 64 is 8 times 8. And so 7 would be the square root of 49. 60 is closer to 64. So we would say that the square root of 60 is about equal to 8. Because again, we're rounding to the nearest integer. Number 9, we have a negative square root again. So let's see. The negative square root of 25 would be negative 5. The negative square root of 16 would be negative 4. So it's somewhere between negative 4 and negative 5. It's closer to negative 5 because 23 is closer to 25. So the negative square root of 23 is about equal to negative 5. Once you're done with your video, make sure you show the substitute, then you can work on worksheet 3.3.